Questions? Okay, so we've got 8 minutes left. I think what I'm going to do is just very briefly introduce the notion of circuits. This is the easiest part of like the entire lecture. So I know it's kind of a bit of a stretch because we only got 8 minutes left, but you're going to like this. It's like very, very straightforward. Okay, so we can represent an electrical circuit just with something called a circuit diagram. Okay, and so let's look at the very simplest circuit that you could ever have, which is just a battery and a light bulb. So remember I said that the way that you represent a battery is like this, where this is the positive terminal and this is the negative terminal. Wires are just like straight lines, okay? And then resistors have this symbol here. Okay, so this is a resistor. So an example of a resistor would be a light bulb, okay? So that's the simplest kind of circuit that you could construct with a battery and a single resistor. The battery produces something called an electromotive force, which is just a fancy way of saying voltage, right? The symbol for that is sort of like a swirly E. It's EMF, and it's the same as the voltage, okay? So you could say that there's like a specific EMF across that battery, right? Like if it's a 9-volt battery, then that would be at 0 volts. That would be at 9 volts, right? So remember, witers are equipotential lines. Equipotential. Or equipotential like surfaces, I mean really lines because they're linear. Okay? So like if I have an EMF of like E or 9 volts, then like what would be the potential there? 9. What would be the potential there? What would be the potential there? Okay, what would be the potential here on this side of the battery? 0, right? So this would be like 9, 9, 9. This would be 0, this would be 0, right? So what we could say is that there's a 9-volt drop of potential across that resistor, right? Because it's going from like right before the resistor, it's going from 9 volts. Right after the resistor, it's going to 0 volts because this wire is an equipotential line. Okay, so the circuit is going to the resistor is going to follow Ohm's law. Okay, so the current is equal to the change in potential over the resistor. So depending on the resistance of that resistor, remember the resistance is a function of both the material and the geometry. So depending on the resistance value of that resistor and the potential drop from like, you know, if it's a 9-volt battery from 9 to 0, we could calculate what the current flowing through that resistor is. Okay, what if you have 2 resistors and you connect them in series? Okay, so what that would look like, so here you've got a battery, same battery, let's say, wire, resistor 1, and then it's connected in series to resistor 2. So this is resistor 2. Okay, what does it mean for it to be connected in series? It means that the current flowing through both resistors is the same. Okay, so current, when you have series, the current is the same. Okay, so let's talk about, so let's say you have an EMF of E. Okay, so this point here would be at E, whatever it is. Okay, this would be at E, this would be at E. Okay, what about this point, halfway in between the 2 resistors? Like if I were to measure the potential here, what do you think that would be? No, just like more conceptually than that. So like this is the potential all along this surface is at, let's go back to the 9 volts. So 9 volts, right? And I know that the potential all along here is at 0 volts. What is going to be the potential halfway in between those two, assuming that R1 is equal to R2? The voltage is just going to be half, right? Or it's going to be like the E divided by 2. Okay? So when you're talking about a series circuit, the current is the same, and the change in potential across each of the resistive components in the circuit is equal to whatever the EMF of the battery is. So like the voltage drop across like resistor 1 plus the voltage drop across resistor 2 is equal to the EMF. Does that make sense? So current 1 is equal to current 2, and like assuming, well actually not even assuming, always, okay, when you're dealing with a series circuit, okay? What must be true about the potential difference across the two resistors? They have to be the same, okay? That's basically what this is saying. Okay, so let's say that we have two resistors. One of them is 5 ohms, and an ohm is just the unit of resistance. Okay, so this one is 5 ohms, and then this one is 10 ohms. Or sorry, 15 we said. In the questions, 15. And we want to know, like, what if I were to replace these two with one resistor, so with the equivalent resistor. So let's call this R equivalent. What would be the resistance of that equivalent resistor? When they're connected in series, it's like very intuitive. It's just the sum, right? So it would just be R1 plus R2, which is 20 ohms. Okay, so in series, you've got the same current. The voltages add. And the resistors add. Okay, and we'll pick up with the resistors in parallel next time. Okay, that's where we'll pick up next week. Okay, see you then.